What are some scientifically proven facts everyone still doesn't believe? Story 1. That most people don't change their minds when presented with facts that contradict their beliefs. It's so true. I've caught myself doing it more times than I'd like to admit. I'll read something that clearly challenges what I believe, and my first instinct isn't curiosity, it's resistance. I feel that subtle tightening, that immediate yeah but, forming before I've even processed the evidence. If I slow down and actually sit with it, sometimes I realize the information is solid. Sometimes I even remember seeing it before and just mentally skimming past it because it didn't fit the narrative I was comfortable with. That's the unsettling part. There have been moments where I thought I'd just discovered I was wrong about something, only to realize the correction had crossed my path months earlier. I just didn't let it land. It's not that we're trying to be irrational. It's that our brains prioritize coherence over correction. You really do have to stay vigilant. Question your own reactions. Notice when you're defending instead of evaluating. Catch that instinct to dismiss before you understand. Because the bias doesn't announce itself. It feels like certainty. Story 2, not being held, loved, or hugged as a child can have long-term consequences in adulthood. That sounds obvious on the surface, but people still underestimate how deep it goes. Early physical affection isn't just emotional. It's neurological. Touch regulates stress hormones like cortisol. It strengthens attachment bonds. It literally shapes how a child's brain wires itself around safety, trust, and connection. Studies on early childhood neglect, including research on institutionalized children, show higher rates of anxiety, depression, attachment disorders, and difficulty forming stable relationships later in life. Chronic lack of affection can keep a child's stress system on high alert, which can carry into adulthood as hypervigilance, emotional numbness, or difficulty with intimacy. We often treat love and physical affection as nice extras. They're not. They're developmental inputs. A child who isn't consistently held or soothed doesn't just miss comfort, they miss regulation. And over time, that absence can echo through relationships, self-worth, and emotional resilience decades later. It's one of those facts that sounds soft, but the science behind it is anything but. Story 3. Seatbelts and airbags save lives. This one shouldn't even be controversial. The physics alone make it obvious. When a car going 40, 60, 80 miles per hour stops suddenly, your body doesn't magically stop with it. It keeps moving at the same speed until something stops it. If that something is a windshield, a steering wheel, or the pavement outside the car, that's not a survivable design. Seatbelts distribute force across stronger parts of your body and prevent ejection, which is one of the deadliest outcomes in crashes. Airbags are designed to work with seatbelts, not replace them, cushioning impact and reducing head and chest trauma. Crash data over decades consistently shows dramatically lower fatality rates for restrained occupants. It's not a debate, it's biomechanics. You can argue about comfort. You can argue about personal freedom, but you can't argue with inertia. If someone wants to test Newton's laws face first through a windshield, that's on them. I'll click mine every time. Story 4. Germ theory, which is wild considering it's one of the most foundational discoveries in modern science. The idea that microscopic organisms, bacteria, viruses, fungi, cause disease has been supported for over a century. We can culture them, stain them, sequence their genomes, watch them infect cells under microscopes. Entire fields of medicine, from surgery to antibiotics to vaccines, are built on it. And yet, some people reject it. Part of it is psychological. Humans evolved to trust what we can see and feel. Invisible threats are harder to intuitively grasp. If you can't see a pathogen floating in the air, it can feel abstract, almost theoretical. But the effects are anything but abstract. Before germ theory became widely accepted, surgical mortality rates were staggering. After antiseptic practices were introduced, deaths plummeted. That wasn't a coincidence. It was cause and effect. You don't have to see bacteria to observe the pattern. Hygiene improves, infection drops. It's one of the clearest scientific revolutions in history. Invisible doesn't mean imaginary. It just means small. Story 5. Essential oils might make your room smell amazing. They might even make you feel better. But they don't cure diseases. There's a difference between aromatherapy and medicine. Certain scents can influence mood or stress levels. Lavender for relaxation, peppermint for alertness. That's about the brain's response to smell and the limbic system. That's not the same thing as killing bacteria, shrinking tumors, reversing diabetes, or curing infections. Modern medicine demands controlled trials, dosage standards, reproducibility, and measurable biological outcomes. If an oil could reliably cure a disease, it wouldn't stay in the wellness aisle. It would be studied, standardized, and prescribed. Natural doesn't automatically mean therapeutic, and feeling better isn't the same as being cured. There's nothing wrong with enjoying essential oils for comfort or ambiance. Just don't confuse scent with science. Your chakras might feel aligned, Your bloodstream doesn't care. Story 6. Mental health is a legitimate part of physical health, not metaphorically. Chronic stress raises cortisol. Elevated cortisol affects immune function, blood pressure, blood sugar regulation, and inflammation. Depression is associated with measurable changes in brain chemistry and neural circuitry. Anxiety disorders correlate with altered autonomic nervous system activity, heart rate, digestion, muscle tension. This isn't all in your head. It's in your nervous system, your endocrine system, your cardiovascular system. Trauma can change how the brain processes threats. Long-term psychological distress is linked to increased risk of heart disease, weakened immunity, sleep disorders, and chronic pain conditions. The brain is an organ. If your pancreas malfunctions, we call it diabetes. If your heart malfunctions, we call it heart disease. If neural circuits regulating mood and stress malfunction, that's mental illness. It's not a weakness, it's physiology. Separating mental from physical health is convenient language, but biologically, they're deeply intertwined. Story 7. The hardest part about arguing with people who disagree with commonly proven science facts is that science isn't perfect. Scientists can be wrong. Old science can be proven wrong. Dishonest scientists can publish crap studies in crappy journals, and they look just as legitimate as something published in Nature to untrained eyes. These people will hold on to these studies and say, look, science proves I'm right, when the paper they chose is 1 in a million. The reason it's hard to argue with them is because it takes so much effort to disprove that crap. It takes so much effort to look through their references and prove their crap, or they've been disproven, and very few people know how to do it. Story 8. Antibiotic-resistant bacteria. This one isn't hypothetical, it's happening. Bacteria evolve fast. When antibiotics are overused or misused, incomplete prescriptions, unnecessary prescriptions, agricultural overuse, we create selection pressure. The weakest bacteria die. The strongest survive. They replicate. They share resistance genes. Over time, the drugs stop working. Infections that were once routine become dangerous again. Surgeries become riskier. Chemotherapy becomes riskier. Even minor injuries can carry higher stakes if effective antibiotics aren't available. This isn't science fiction. Hospitals already track resistant strains like MRSA and drug-resistant tuberculosis. Public health agencies worldwide classify antimicrobial resistance as a major global threat. Modern medicine depends on antibiotics more than people realize. They're the quiet backbone behind countless procedures. If we lose them at scale, we don't just lose a drug, we lose a safety net. It wouldn't send us back to the Stone Age, but it could make parts of medicine feel a lot more like the 1800s. Story 9. The common cold is not caused by cold weather. You don't catch a cold because it's cold outside. You catch a cold because of viruses, most commonly rhinoviruses. Temperature by itself doesn't create an infection. You can stand in freezing air all day and never get sick if you're not exposed to the virus. Illness requires a pathogen. So why does it spike in winter? Because behavior changes. People spend more time indoors. Windows stay closed. Ventilation drops. We cluster in heated spaces, sharing air. Viruses spread more easily in dry air, and cold conditions may help viral particles remain stable longer. Some research also suggests cold, dry air can slightly reduce the effectiveness of nasal immune defenses, but that's the influence, not cause. Cold weather doesn't generate sickness out of nowhere. It just creates better conditions for viruses to move from person to person. You don't catch a chill, you catch a virus. Story 10. Depression exists. Autism exists. ADHD exists. OCD exists. Not as trends, not as excuses, not as personality quirks. As measurable, diagnosable conditions. Depression is associated with changes in neurotransmitters, brain connectivity, sleep regulation, and stress hormones. It's linked to increased inflammation and altered activity in specific brain regions. Autism spectrum disorder involves differences in neural development that affect communication, sensory processing, and social interaction. Brain imaging studies consistently show structural and connectivity differences, not defects but variations. ADHD is tied to differences in dopamine regulation, executive function networks, and impulse control circuitry. It's one of the most studied neurodevelopmental conditions in children and adults. OCD involves hyperactivity in brain circuits related to threat detection and habit formation. It's not being neat, it's intrusive thoughts and compulsions rooted in neural loops that are hard to disengage. These aren't moral failings, they're neurobiological realities. Dismissing them doesn't make them disappear, it just makes the people living with them feel invisible. Story 11. Germs cause disease. It sounds elementary, but it took centuries and millions of deaths before humanity accepted it. Bacteria, viruses, fungi, and parasites are microscopic organisms that invade the body, replicate, and disrupt normal function. We can observe them under microscopes. We can culture them in labs. We can sequence their DNA. We can track outbreaks genetically from person to person. Before germ theory, people blamed bad air, curses, imbalances, or fate. Then sanitation improved. Hand washing was introduced in hospitals. Sterilization became standard. Mortality rates dropped dramatically. That wasn't a coincidence. That was cause and effect. Antibiotics target bacteria. Vaccines train the immune system to recognize specific pathogens. Antivirals interfere with viral replication. Every one of those tools only works because germs are real and disease has biological origins. You don't have to see bacteria with your eyes to be affected by them. Invisible doesn't mean imaginary, it just means microscopic. Story 12. The Monty Hall problem. 3 doors. 1 prize. You pick one. The host, who knows where the prize is, opens a different door, revealing a goat. Now you have a choice. Stick with your original door or switch to the remaining unopened one. Most people feel it's 50-50. It's not. When you first choose, you have a 1 in 3 chance of being right. That means there's a 2/3 chance the prize is behind one of the other 2 doors. When the host reveals a goat, and crucially, always reveals a goat, that 2/3 probability doesn't disappear. It transfers to the single remaining unopened door. Switching gives you a 2/3 chance of winning. Staying gives you 1/3. It's been simulated thousands, even millions of times. The math holds, the results repeat. And yet people argue, because intuition says the odds reset. They don't. The problem isn't complicated math, it's that probability doesn't always feel right. And when logic clashes with instinct, instinct usually wins, at least at first. Story 13. Astrology. Your birthday has nothing to do with your personality. Not in the way horoscopes claim. The position of constellations at the time of your birth doesn't influence your temperament, your compatibility, your ambition, or your emotional patterns. Large-scale studies comparing astrological predictions to real personality measures consistently fail to show reliable correlations. What explains why it feels accurate? The Barnum effect. People tend to accept vague general statements as highly personal if they believe they're tailored to them. You value loyalty but sometimes need time alone. That applies to almost everyone. When you read it under your zodiac sign, it feels specific. There's also confirmation bias. When a description matches you, you remember it. When it doesn't, you ignore it. Meanwhile, personality is influenced by genetics, upbringing, culture, environment, and lived experience. Not whether Mars was in retrograde. You can enjoy astrology as symbolism, storytelling, or entertainment. Just don't confuse cosmic poetry with causal science. They're just not running your brain. Story 14. Non-physical forms of abuse are real and are just as damaging, if not more so, than physical forms of abuse. The only kinds of disability that count as such are the visible kinds, that is, someone uses a white cane, wheelchair, braces, or prosthetics, etc. ETA. It was kindly pointed out to me that I actually meant the opposite of this bit here, that people still don't believe invisible illnesses or disabilities count. Whoops. Mental health matters and is real. Vaccines work. Evolution is a real observable process. Story 15. Addiction is a disease, not a moral failing. And a lot of people still resist that idea. Addiction changes the brain. Repeated substance use alters dopamine pathways, reward circuits, impulse control systems, and stress responses. Over time, the brain becomes less responsive to natural rewards and more driven toward the substance. Cravings aren't just wanting, they're neurological reinforcement loops. Brain imaging studies show measurable differences in areas tied to decision-making and self-control. Withdrawal symptoms are physiological. Tolerance is biological. Relapse risk is tied to stress chemistry and environmental triggers. None of that means behavior doesn't matter. It means the playing field changes. Calling addiction a moral failure assumes equal neurological footing, that it's simply a matter of willpower. But diseases like diabetes also involve behavior and management, and we don't frame insulin resistance as a character flaw. Addiction involves choice at the beginning. Over time, it involves compulsion shaped by altered biology. Recognizing it as a disease doesn't remove responsibility. It reframes treatment from punishment to recovery. Story 16. Animals have emotions, not projections. Real, measurable emotional states. Mammals share much of the same brain architecture we do, including structures like the amygdala and limbic system that regulate fear, bonding, stress, and pleasure. Studies show dogs experience attachment responses similar to human infants. Rats display empathy-driven behavior. Elephants show signs of grief. Primates demonstrate jealousy, cooperation, and reconciliation. Neurochemically, it's not that different either. Oxytocin rises during bonding, cortisol rises under stress, dopamine reinforces reward. The machinery is there. What animals may lack is the same language or abstract reasoning we use to describe feelings. But the experience of fear, comfort, play, distress, and attachment, that's well supported. The resistance often isn't scientific. It's psychological. If animals feel deeply, then how we treat them carries more moral weight. Dismissing their emotional capacity makes cruelty easier to justify. The science is increasingly clear. They aren't emotionless. They're just not human. Story 17. The effects of the internet are real, measurable, and far more profound than most people admit. The internet has changed the way our brains process information. Studies show that constant exposure to fast, high-volume digital content trains the brain to favor quick scanning over deep reading. Attention spans shorten not because people are lazy, but because the brain adapts to environments that reward rapid shifts in focus. When notifications, short videos, and algorithm-driven feeds constantly interrupt us, sustained concentration becomes harder. Social media platforms also affect mental health in measurable ways. Research has found correlations between heavy usage and increased rates of anxiety, depression, sleep disruption, and loneliness, especially among adolescents. The comparison effect, seeing curated highlights of others' lives, can distort self-perception and amplify feelings of inadequacy. Algorithms further intensify emotional content because outrage and strong reactions drive engagement. The internet has brought immense benefits in communication and knowledge access. However, it has also rewired reward systems, reinforced polarization through echo chambers, and altered how we form opinions. The changes are not imaginary, they are behavioral, neurological, and cultural, and we are still living through the experiment. Story 18. Time literally slows down the faster you go, or the deeper you are in a gravity well. I know that sounds like sci-fi nonsense, but it's not theoretical. It's been measured. According to Einstein's relativity, if you move really fast relative to someone else, your clock ticks slower than theirs. Not metaphorically, actually slower. Astronauts on the ISS age slightly less than people on Earth because they're moving so fast. The difference is tiny, but it's real and measurable with atomic clocks. Gravity does it too. The stronger the gravity, the slower time moves. Clocks on satellites tick slightly faster than clocks on Earth's surface because they're farther from Earth's gravity well. If we didn't account for that, GPS would drift by miles pretty quickly. Your phone works because engineers correct for time literally moving at different rates. If you were near a black hole, the effect would be extreme. To someone far away, your time would crawl. So yeah, time isn't universal. It's stretchy. We all just live at roughly the same speed most of the time, so it feels normal. But physics says otherwise. Story 19. Quantum computing is real. Not theoretical. Not sci-fi. Not maybe someday. Classical computers use bits, 0s and 1s. Quantum computers use qubits, which can exist in superposition, meaning they can represent 0 and 1 at the same time until measured. On top of that, qubits can be entangled, so the state of one is directly related to the state of another, even when separated. That's not philosophy. It's experimentally verified quantum mechanics. Companies like IBM and Google have already built working quantum processors. They're not replacing your laptop anytime soon, but they can perform certain calculations in ways classical machines fundamentally can't replicate efficiently. The hype gets out of control, sure, but the underlying physics isn't hype. Quantum systems already factor large numbers in lab conditions, simulate molecules, and explore optimization problems in new ways. The hardware is fragile and error-prone right now, but it exists. It sounds fake because it violates intuition. Particles being in two states at once shouldn't make sense, but the math works. And the machines are running. Story 20. The Earth orbits the Sun. I know this sounds like something we all agreed on in middle school, but you'd be surprised how many people still question it or treat it like just a theory. It's not up for debate. We can measure planetary motion with telescopes. We can track retrograde motion of planets like Mars, which only makes sense in a heliocentric system. We can calculate orbital mechanics precisely enough to send spacecraft to other planets using equations based on the Sun being the central mass. Satellites, interplanetary probes, eclipses, all of it depends on Earth moving around the Sun. If Earth were stationary, the math would fall apart instantly. The heliocentric model explains seasons, planetary phases, stellar parallax, and gravitational dynamics in a way that matches observation perfectly. It's not a philosophical preference, it's predictive physics. The wild part is that this was controversial centuries ago. Now it's demonstrable with high school level equipment and basic astronomy observations. We are not the center, we are on a rock, moving around a star, right now. Story 21. Evolution by natural selection is real, not just a theory in the casual sense. A scientific theory meaning it's supported by massive amounts of evidence from genetics, paleontology, biology, and direct observation. Species change over time. We can see it in the fossil record, we can measure it in DNA, we can watch it happen in fast-reproducing organisms like bacteria and viruses. Antibiotic resistance? That's evolution in action. Viruses mutating? Evolution. Selective breeding in dogs and crops? Same mechanism, just human-guided instead of environmental. Natural selection is simple at its core. Variation exists. Some variations provide survival or reproductive advantages, and those traits become more common over generations. No grand plan. No ladder toward higher life. Just differential survival. The evidence lines up across independent fields. Genetics confirms relationships predicted by fossils. Comparative anatomy matches DNA sequence. Embryology shows shared developmental pathways. You don't have to like it, but the biological data is overwhelming. Evolution isn't a belief system. It's the framework that makes modern biology make sense. Story 22. Depression, schizophrenia, and just mental issues and sickness in general. Seriously, the amount of people who think that mental issues don't exist, and everyone just overthinks it and can just get rid of it if they just stop being stupid or pretending for attention. So many people say stuff like, depression doesn't exist, just go outside, or, I have never seen a so-called schizophrenic attack a big strong boxer, one hit in the face, and they will go back to normal. The last one was said by a radio host on state radio during discussion of mental health. I've seen what mental sickness can do to people and those around them. It destroys lives. It's infuriating how ignorant people can be on that question and how proudly sure in their ignorance they are. Story 23. Anxiety is just as serious as depression. People tend to treat anxiety like it's just worrying too much, like it's personality, like it's overthinking. It's not. Chronic anxiety keeps your nervous system in a near constant fight-or-flight state. Elevated cortisol, increased heart rate, muscle tension, sleep disruption. Over time, that kind of sustained stress wears down both the body and the mind. It's exhausting. And yes, prolonged anxiety is a major risk factor for developing depression. When your brain is constantly scanning for threat, constantly anticipating worst-case scenarios, constantly on edge, it drains your emotional bandwidth. Eventually, that hyperarousal can flip into hopelessness, into numbness, into what's the point? And when you're stuck in a place where you don't want to be, where you feel bad even when things are objectively good, that's not a weakness. That's a nervous system under strain. If you're feeling like nothing is worth living for right now, that's heavy. And it matters. You don't have to carry that alone. If you're in the US, you can call or text 988 for the Suicide and Crisis Lifeline. If you're elsewhere, I can help you find a number where you are. If calling feels like too much, even reaching out to one person you trust and saying, "I'm not okay," is a start. Anxiety and depression are treatable. They distort perception. They lie about permanence. What you're feeling is real, but it isn't final. Story 24. Nothing in science is ever proven in the absolute mathematical sense, and that's not a weakness. In mathematics, you prove things deductively from axioms. In science, you build models that survive testing. A scientific law describes a consistent pattern we observe in nature. A scientific theory explains why that pattern exists and makes predictions that can be tested. If those predictions keep holding up, across experiments, across decades, across independent researchers, confidence increases. But certainty, absolute, untouchable certainty, that's not how empirical knowledge works. Science is provisional by design. It says, this is our best explanation given the current evidence. If better evidence appears, the model updates. That willingness to revise is what separates science from dogma. When people say science proves, they usually mean overwhelming evidence supports. They don't mean metaphysical finality. Gravity isn't proven the way a geometry theorem is proven. It's supported by mountains of converging data that make alternative explanations collapse. Science doesn't claim infallibility. It claims repeatability, falsifiability, and predictive power. And that humility, that built-in uncertainty, is exactly why it works. Story 25. Nuclear power is significantly safer than most other forms of energy production. That sounds insane to a lot of people, because when nuclear goes wrong, it goes wrong publicly and dramatically. Names like the Chernobyl disaster and Fukushima Daiichi nuclear disaster are burned into collective memory. But here's what the data shows. When you look at deaths per unit of energy produced, including accidents and air pollution, nuclear is among the safest major energy sources ever deployed. Coal kills far more people every year through air pollution alone. Oil and gas extraction have routine industrial fatalities. Even hydropower has caused catastrophic dam failures with massive loss of life. Nuclear incidents are rare, heavily studied, and have led to increasingly strict safety designs. Modern reactors are built with passive safety systems that don't rely on human intervention to shut down safely. The fuel is incredibly energy dense, meaning a tiny amount produces massive output with minimal emissions. Fear is understandable. Radiation is invisible. Nuclear accidents are dramatic. The word itself carries Cold War baggage. But statistically, per terawatt hour produced, nuclear has caused fewer deaths than most fossil fuels. It feels dangerous. The numbers say otherwise. Story 26. Water itself is not a conductor of electricity. That surprises people. We grow up hearing water and electricity don't mix, so it feels obvious that water must conduct electricity. But pure water, distilled deionized H2O, is actually a very poor conductor. Electricity flows through charged particles. Pure water has almost none. What makes water conduct electricity is the stuff dissolved in it: salts, minerals, impurities. Tap water conducts because it contains ions like sodium, calcium, and chloride. Seawater conducts extremely well because it's packed with dissolved salts. If you had perfectly pure water in a lab setting, it would resist electrical flow far more than people expect. So when someone gets shocked in water, it's not because water conducts. It's because the water isn't pure. The difference matters. Water isn't inherently conductive. Impurities are. Story 27. Reversing baldness isn't some solved, secretly cured condition that's being hidden. If there were a simple, permanent, universally effective cure for male pattern baldness, it would be everywhere. The market incentive alone would guarantee it. What we do have are partial treatments. Drugs like minoxidil can slow hair loss and sometimes regrow hair by extending the growth phase of follicles. Finasteride works hormonally by reducing DHT, which contributes to follicle miniaturization and androgenetic alopecia. Hair transplants redistribute existing follicles from resistant areas to thinning ones. But none of these fully reverse baldness in a biological reset sense. They manage it. The core issue is that in common pattern baldness, hair follicles gradually shrink and produce thinner, shorter hairs until they stop producing visible hair. Reactivating long dormant or fully miniaturized follicles in a consistent, permanent way is biologically complex. There's ongoing research into stem cells, follicle cloning, and regenerative medicine. Progress exists, but no magic switch yet. If you feel like a breakthrough happened and you missed it, you didn't. We're still in the manage and mitigate phase, not the restore at will phase. Story 28. Zero-till farming is often more effective than conventional tillage. It sounds counterintuitive because for centuries farmers have plowed fields to prepare soil. Turning the soil feels productive, it looks clean, it looks ready. But tilling disrupts soil structure. It breaks apart fungal networks. It accelerates erosion. It exposes organic matter to oxygen, which increases carbon loss. Over time, that can reduce soil health. Zero-till or no-till farming skips the plow. Crops are planted directly into the residue of previous crops. That leftover plant material protects the soil surface, reduces erosion from wind and rain, improves water retention, and encourages microbial life. Healthier soil holds more water, holds more carbon, requires fewer passes with heavy equipment. In many systems, that means lower fuel costs, less runoff, improved long-term soil fertility, and competitive, sometimes higher, yields. It's not magic, and it doesn't work identically in every climate or crop system. Weed management can be more complex. Transitions take time. But the data from long-term agricultural studies consistently shows improved soil structure and resilience under no-till systems. Sometimes doing less disturbance produces more stability. And stability, in farming, is power. Story 29. The metric system is leagues better than the imperial system, at least when it comes to logic, consistency, and global use. The metric system is base 10. Everything scales by powers of 10. Millimeters to meters to kilometers. Grams to kilograms. Liters to milliliters. Conversions are just moving a decimal point. Imperial, 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, 16 ounces in a pound. There's no clean pattern. You memorize it or you look it up. More importantly, the metric system, specifically the SI International System of Units, is the standard used in science worldwide. Physics equations, chemistry measurements, medical dosing, engineering specs, international research papers, all rely on metric units because they're coherent and interoperable. When NASA lost the Mars Climate Orbiter in 1990 due to a metric or imperial unit mix-up, it wasn't a theoretical problem. It was a multi-million-dollar reminder that consistency matters. Imperial can feel intuitive for everyday life if you grew up with it. But for precision, scalability, and global collaboration, metric wins. Not because it's trendy, because it's structured. Story 30, the history of the planet, and even the universe, is far older and far more well-established than many people think. The Earth is about 4.5 billion years old. That number doesn't come from guesswork. It comes from radiometric dating, measuring the decay of radioactive isotopes in rocks and meteorites. Independent methods converge on the same age range. When different techniques point to the same answer, confidence increases. The universe is about 13.8 billion years old. That estimate comes from multiple lines of evidence: the expansion rate of galaxies, the cosmic microwave background radiation, and models of stellar evolution. Observations from missions like Planck spacecraft refined those measurements with remarkable precision. We can see galaxies billions of light years away, meaning we're looking back in time. We can observe star formation, supernova remnants, and cosmic background radiation, relic signals from the early universe. None of this relies on a single fragile assumption. It's layered evidence. Geology, astrophysics, nuclear physics, and cosmology all align on timelines that stretch billions of years. The scale is hard to emotionally grasp, but the data is consistent. The universe is ancient, and we arrived very late.